Lesson 25. We're looking at example 5b in this case. Now, what you need to know in terms of doing these problems is that I'm keeping this note paper right here really close by. All we're doing is we're going to go through those formulas all over again. I want to take the equation that looks like this. In this case, it looks like this one right here, this 32x squared minus 48xy plus 18y squared minus 15x minus 20 is equal to 0. I'm going to take that particular equation, and I'm going to change it so that it looks like this, such that it doesn't have that xy term. Okay, without that xy term, I don't have any shifts. So what I'm going to start with is this cotangent of 2 alpha a minus c divided by b. I'm going to go ahead and solve that thing first. Okay, I'm going to solve that thing first. So I'm going to go ahead and look at this. I'm going to write that down. 32 minus 18, my a value being 32, my c value being 18, my b value being the negative 48. I have 32 minus 18, which is going to be a value of 14, divided by the negative 48. That means I'm actually going to get a negative rotation, or actually a negative value. It doesn't necessarily mean a negative rotation. So that's going to give me 14 divided by 48 is going to be a value of, it's not going to be a perfect number. So what I'm going to do is I'm going to do it to the best of my ability in terms of simplification. This is going to be a negative 7 over 24. Okay? Well, if that's the case, and this is cotangent, let me figure out where this is going to be. This looks like a triangle, if I'm not mistaken. So let's go ahead and do that. Let's look at a triangle here. Well, cotangent negative 7 over 24, or 7 over 24. This is all positive. This is all students sine and cosine. This is tangent, and this is cotangent, or sorry, cosine. So where is cotangent going to have negative value and a positive value? Well, either it'll be here or here, right? One of these two places. Well, we're going to go ahead and move it into this triangle over here. Okay, so I'm going to have a negative 7 and then a positive 24. So my triangle has this looking thing right here. Okay? So what's this value going to be if this is negative 7 and this is 24? I'm sorry, 24 would be here. Okay? This right here would actually be 25, because this is going to be one of those Pythagorean triples. Again, you can go ahead and do 7 squared plus 24 squared is equal to this 25 squared, but I'm just saving the trouble. That's where it is. Okay? Now, if that's the case, I still need to be able to find the angle alpha. Okay, I need to find the angle alpha. Well, there's a couple of different ways that we could do this. Probably the easiest way would be typing into the calculator. I'm going to go ahead, but wait a second. This is 2 alpha. This is 2 alpha. That's a problem for us. I don't want 2 alpha. I want alpha equals. Okay, and no, you can't just go ahead and find the angle of this and then divide it by 2. That's not going to work that way. So what I'm going to have to do is I'm going to have to use an identity. And what we end up doing is we end up using the identity in terms of the half angles. Yes, I know we very rarely try to use those, but in this case that's what we're going to do. I know that the cosine of 2 alpha, I'm going to start there, the cosine of 2 alpha is actually equal to adjacent negative 7 over 25. That's going to be helpful, okay, because when I use my half-angle identities say the sine of alpha is equal to the square root of 1 minus the cosine of 2 alpha divided by 2. Likewise, the cosine of alpha is equal to the square root of 1 plus the cosine of 2 alpha divided by 2. Well, if that's the case, these are nice and easy. I can plug these values in and get 1 minus a negative 7 over 25, all divided by 2 inside this square root. We get that this thing is just a number 4 over 5. And again, that's all it is, if we do the simplification correctly. If you don't do the simplification correctly, this isn't going to work out. Likewise, I'm going to do the same thing here. This is 1 plus a negative 7 over 25 divided by 2. Simplifying this one, I get this as 3 over 5. Wait a second. If this is 3 over 5 and 4 over 5, isn't the triangle that I'm working with in terms of alpha just being that sine being something that looks like this. Sine is 4, cosine is 3, this is 5. Aren't I just working in this triangle right here? And all I really need to do is determine what that alpha is. Okay. How can we determine what that alpha is? Well, either case, sine of alpha is equal to 4 over 5. That implies that the alpha is equal to sine inverse of 4/5. Now, I'm going to go ahead and do that in my calculator and see what happens. I'm going to go ahead and make sure my mode is in degree, because if it's in radian, we're going to get a decimal value that's not going to make any sense. I'm going to go ahead and take sine inverse. The sine inverse of 4 divided by 5. And it's going to tell me 53.1. So over on my paper here, I'm going to go ahead and this is approximately equal to 53.1. I'm going to do the same thing just to check. The cosine of alpha is equal to 3/5. And that's supposed to be alpha is equal to the cosine inverse of 3/5. And that's approximately equal to, doing the same thing in my calculator. Okay. I'm going to clear that out, and cosine inverse of 3 divided by 5. 53.1 again. So that is my alpha, my angle of rotation, 53.1. Now, this means that a lot of this stuff is not going to be very pretty. However, finding these values right here are going to help us in evaluating all of the formulas. Again, if you look at these formulas, I have cosine of alpha. Cosine of alpha is 3/5. I have sine of alpha. Sine of alpha is 4/5. There's no need to use this angle measure for us to determine the extra values. All we need that angle measure for is to give us an idea of how this thing is rotating. So, let me go ahead through excuse me, the rest of this information. I have A is equal to 32. B is equal to a negative 48. C is equal to 18. D is going to be, again, corresponding to the x value, so that's a negative 15. My y corresponds to the y value, so that's negative 20. Oh, sorry, E, that's E. E corresponds to the y. And then my f value is 0, because I don't have any constants. Again, I'm looking at this formula, A, B, C, D, E, and then no f. Now, I want to change these to A prime, B prime, C prime, E prime, D prime, and F prime. So, F prime is always the same thing as F, so that's 0. I'm going to go ahead and do E prime and D prime. And again, keeping this formula sheet very close to me, I'm going to go ahead and type all those values in. For E prime, I have a negative D times the sine of alpha. Sine of alpha, remember, we found up here, 4/5. So that's times 4/5. That's going to be plus my E value, which is a negative 20, times the cosine of alpha, which is 3/5. Okay, that's going to give me a value of the 15 is going to cancel out with the 5, gives me a 3. Negative times negative is positive. 3 times 4 is 12. So it can be 12 minus 12 here, minus. Well, 20 divided by 5 is 4. 4 times 3 is 12. Isn't that just 0? Again, if you don't trust me, go ahead and do the math. I believe that's just going to be 0. Let's go ahead and do D prime now. D prime is going to be a value of D, negative 15, times the cosine of alpha. Cosine of alpha is 3/5. Plus my E value, which is a negative 20, times the sine of alpha, which is a 4/5. Now that number there is going to be 15 cancels out with the 5 and gives me a negative 5. Negative 5 times 3 is a 15, so this is just going to be 15, negative. Right here, I'm going to have this and this cancel out, and that's going to leave me with a negative 16. So negative 15 minus negative 16 looks like a negative 31. Okay? I did that math wrong somewhere. Let me check that one more time. This will be 9, not 15. Sorry, this will be 9 minus that. This doesn't end up being negative 31. It ends up being negative 25. Okay? Let's talk about C prime and then lastly A prime. Those are the last two I need to work with. And those two, again, utilizing the formula sheet, are going to be working up. C prime is A. A is a value of 32. Times sine squared, so 4/5 squared. Minus my B value, which is a negative 48. Times the cosine of alpha, 3/5, times the sine of alpha, 4/5. plus my c value, which is 18, times the cosine squared, so 3/5 squared. If we do all that math, I'm not going to do that in my head, we get a value of 50. And lastly, a prime. I would suggest that you do that just to check it again, but I believe the value ends up being 50. For a prime, we're going to have all those values being plugged in again. 32 times the cosine squared, so we're going to have this time 3/5 squared, plus a negative 48 times 3/5 times 4/5. Plus my c value is 18, and sine squared, which is going to be 4/5 squared. With all those numbers plugged in, that ends up being 0, which is actually quite nice. So, what do we have? Well, let's go ahead and let me type in all this information. My c prime always corresponds to the y, so I have 50 y squared. Again, a corresponds to the x squared, c corresponds to the y squared, d corresponds to the x, so it's going to be minus 25x equals to 0. That's it, because everything else is 0. And again, I'm going to write this down, rotated 53.1 degrees. That's the graph I'm looking at, and it's rotated like this. So this is clearly going to be a parabola. Let's go ahead and determine what the parabola is supposed to look like. So, first thing I always do is I'm going to go ahead and get all my y's to one side, all my x's to the other. So I'm going to actually go ahead and see that this is y squared is equal to a 25x, adding this to both sides, divided by 50. So y squared is equal to a 1/2 x, but I want that to be 4 times p, so y squared is lastly equal to a 4 times 1/8 x. That means my p value is equal to a 1/8, and it's positive, so that means that the set of axes that I'm going to have rotated 53 degrees. This is my new x and this is my new y. It's going to be a parabola in the y squared direction. This is the y, so that means it's going to be squared going this direction here. And it's going to have its vertex at the origin coming out this way with a distance of a 1/8 between the vertex and the focus. Again, if you want to see this over here, we can draw this here, and that distance from here to here will be 1/8. Again, that's what the p-value is always. It's always that distance of 1/8. Let me zoom that in. So again, it's the parabola that sits in this direction generally, but we rotated it 53 degrees in that direction, where it has a focus sitting right here at a distance of 1/8, so it would be technically 1/8, 0. And that completes problem 5b. Again, this is a nasty problem. They both are, 5a and b. But look at it this way. I'm not going to ask that you do many of these, but you do need to recognize what kind of graph they are, how to deal with them, and especially if you do see an xy term, know that there's going to be some sort of rotation occurring with this. Again, if you see an xy term, know that there's going to be rotation occurring, and you're going to have to use this block of information right here. Okay, all of these formulas and this rotation formula. Notice in this problem, and I'm going to say this one last piece, we got sine of alpha and cosine of alpha. We didn't have to. It made our life easier because then all these numbers were very clear, crisp, and nice. Do this every time. If I'm giving you a number that's not nice and you have to use a triangle, use the triangle. Use the triangle to find sine alpha and cosine alpha, specifically with your half angle. We'll go ahead and look at the last 4 problems on the next video.